Good evening, welcome to my laboratory. This is my partially completed build of the one of the many Akula circuits. I do not yet have the DCDC converter chip. The MC34063A is not arrived yet. So what I'm doing now is just testing the output side, the inverter chip and the Mosfet. I have an IRF3205 Mosfet in there, and that's a CD4069 hex inverter chip. So this is testing the output stage, and what I'm doing is I have 3 volts power from, oops, sorry about that, focus, damn it. I have 3 volts power to the board coming in here, so that's powering the chip, and then I am monitoring the Mosfet drain with 1 oscilloscope channel, and I'm injecting a signal from the function generator into the pin 13 input of the inverter, which is then driving the Mosfet stage. And I'm using a sine wave at 269, 270 hertz right there. Okay, so here's where the baselines are. This is the signal from the function generator, and then this is the Mosfet drain here. So if I turn the channels on, you see the Mosfet drain is at 2 volts per division, so you can see that it goes up to 3 volts just like it's supposed to. It goes up to the supply voltage. The function generator, when I turn on the crank the function generator sine wave up, more and more amplitude, there you can see the Mosfet drain starting to turn on. So, and this is at a voltage of let's see, this is also at 2 volts per division, so this is just over 3 volts peak to peak right now. Okay, and then as I give it even a little bit more amplitude, what you can see is that the on time, the time that the top part of the gate signal is over the threshold voltage, makes the Mosfet turn on for a longer and longer period of time, right? Okay. But notice that actually what is happening is it's turning off there. The top, since this is inverted, the Mosfet's turning off and it's trying to turn on in those little portions. So if I give the system just a little bit more supply voltage here, right now it's sitting at 3 volts, but I'm going to turn it up just a little bit. See what happened there? The drain voltage went all the way down to 0, which means that now the Mosfet is turning fully on in those little portions right there. And then there's that weird little peak there. This is a very interesting waveform. Just over 3 volts, just a hair over 3 volts is needed. I think with this particular Mosfet, the IRF3205, straight 3 volts probably isn't going to cut it. But there you can see that the Mosfet is definitely turning on. It's got that little thing, and then turning all the way off at the tops of those square peaks there. Alright, thanks for watching. Oh, sorry, there was one other thing. Okay, right now I have the supply voltage to the chip turned all the way down. Now I'm going to slowly turn it up. Up, 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 up. There's 3 volts. Now if I go above 3 volts, I'm still turning up, 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 up. Now the Mosfet is turning on. Now the Mosfet is fully on. And that's at an input voltage of about 3.5 volts with no gate signal. Now when I turn up the gate drive, boom, there the MOSFET's turning off, actually, because of the inverter, and as I turn up more and more gate drive, that off time gets longer. But if I turn the gate drive down just to the right spot, I can get a pretty darn narrow, spiky little peak where the MOSFET's turning off for a very, very short period of time. This is all very, very sensitive to the supply voltage to the inverter chip. If I turn that supply voltage down a little bit, you can see what happens. There the MOSFET is completely off. Now I'm turning the supply voltage up again. There the MOSFET is turning partially on, further and further up. Now you get that, and now the MOSFET is fully on, turning the voltage, supply voltage back down, 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 back to 0. Okay, that's it. Thanks.